Good morning, geometry folks. Welcome to another beautiful day here at Fellowship Christian. Sorry I can't be there again. The government has decided that they needed me for a second day. We'll see how it goes for the rest of this week. But for at least today, I am not going to be there. I will be doing a help session tonight, however, on Instagram Live. So make sure you follow Virtual Mr. Coach. The handle is on Google Classroom. So if you guys follow that, I will be performing a Instagram Live. I'm thinking around 9 o'clock tomorrow. So today we're talking about assumptions and justifications. Again, we're going to learn how to argue mathematically. And we've got some things that we can assume and some things that we cannot assume based on looking at a graph or a diagram in this case. So some things we can assume. We've got straight lines and angles. We can assume that if I was to draw a line, even without the magic of my device, I could assume that that line was straight, and I could assume that the measure of that line would be 180 degrees. I can assume collinearity of points. And that's just a fancy way of saying if I had a line and I saw that A, B, and C were on that line, I could assume those points were collinear. And even further, I could assume that point D will fall on that same line eventually if I were to draw a line. The betweenness of points. Same idea. If I've got a line and I've got A and C, I could assume that B is between both of my points. And then, of course, relative position. Where do they sit on the line? So we're going to stick with our red line. I can assume A is on the left, C is on the right, or circle, whatever this thing wants to do. C is on the right, B is between them. I could assume stuff like that. Now, what I cannot assume is right angles. This is going to be the biggest one that you guys are going to want to come up with, or as David says, he's going to want to bust out the old protractor and be like, well, Coach Oliver, I can see that this angle is 90 degrees. Well, unless they tell us it's 90 or we prove that it's 90, I cannot assume this angle. No way. Now what will happen is if I have the same angle and they drop my little right angle symbol, now I can assume that one. So yes way. Okay. So if I just have my little line, I cannot assume that it's right. They've either got to tell me like they do in the blue, or we need to prove it. We cannot assume congruence. So what's going to happen is they're going to give me a line, and then we go back to our line that we had earlier, where A, B, C. What I can assume is that BC is congruent to AB. I cannot assume that B is the midpoint. I have got to be able to prove that stuff, or that's something, again, that they need to tell me. Congruent angles, same idea as right angles. All this stuff is coming from, so I can't assume that those two angles are congruent because we don't know. We've got to prove it, or they've got to tell us. And then again, relative size of segments and angles. There's just too many things that go in to our printing or display or any of that stuff. So I can't assume that any of those lines are the same length. So I've really just got to be careful. If it's a measure outside of that straight angle of 180, I am not going to be able to assume anything about a number. I can assume some of my postulates and theorem because they've been proven. So on Google Classroom, I've included a postulates and theorem sheet that you guys are going to use for your homework tonight, but I'm also going to use it on our notes here a couple of times. So let's look at our pictures we got. So we're just going to go through a couple of things. Now we could go 1:2 and all that stuff, but we're just going to come with some of the big ones that is present in our picture. So we look at our first one. I've got a line being cut by a transversal, and I've got angle 1 and angle 2. So we can assume that this is a straight line. That is something we can assume. Okay. So because of that is straight, we know that that relationship is a linear pair. So we've got some stuff that because of our rules, and you guys are going to be like, well, Coach, this is terrible. What am I supposed to do? But it's just going to be practice. It's going to be repetition. It's going to be trying to figure stuff out and get our own answers. Again, what can we prove here? Okay, so I've got a line. We're just going to go with a couple. I can assume that it's straight. I can assume A, B, and C are collinear. Pretty sure I just spelled collinear wrong. No, we're good. I can assume that. And then if I want to get real technical, I could say B is between. Again, you can go real and be like, oh, well, A is left of B and C is right of B and stuff like that. But I'm not worried about that as much. Okay, the third one. I know what you want to do. You want to say, Coach, that's a right angle. But we cannot assume right. We cannot assume right. So we cannot assume that these are complementary angles. The only thing we know is that 3 is next to 4. So we know angle 3 and angle 4 are adjacent. So you guys see our first example. Straight, we could assume that straight line, so we could assume that was a linear pair, and we can assume that supplementary relationship. Complementary is not as easy because we cannot assume a right angle, so we can't assume that relationship. So it looks like I didn't give ourselves much room here. So we're just going to pick one. We're going to say, we know our line's straight, obviously. And something a little different. I don't have any vertical angles. So let's go with 9 and 8. That's our linear pair. Okay. Same thing, DMF. We can assume that M is between. What we cannot assume is that M is the midpoint of that segment. And again, it looks like they just kind of gave us the same ones. We can assume that 10 and 11 are adjacent. So let's look at our picture down here. We've got a lot of stuff going on. So we want to determine if what we have is true or false based on our image to the right. So it looks like we've got what would appear to be a square or a rectangle being inscribed between two parallel lines, which we learned about last week. So there's a couple more things that come to play. Can we say angle B, C, E and angle EDC form a linear pair? Is this angle and our blue angle, are those forming a linear pair? We cannot assume that because they're not on the same transversal, so that's a false. I'm going to erase that. Can we assume that AB is perpendicular to EC? Well, they don't intersect, so they can't possibly be perpendicular. So that's going to be false. Can we assume that angle ABE and EBC are complementary? So in order to be complementary, they need to show 90 degrees. And if I erase my fancy lines here, you guys will see that I've got that right angle showing. So yes, we can assume that those are complementary. Angle ABE is congruent to EBC. ABE is congruent to EBC. So we cannot assume that because we do not know if that is a perpendicular bisector. Can we assume EBC is 90? We cannot because there's obviously being cut. And can we assume C is the midpoint of BD? False. Cannot assume length. C is between B and D. Yes, we can assume betweenness. And that BD is parallel to AE. So we're not going to be able to assume it, but I bet we can prove it. So as you guys can see, there's a lot more falses than there are trues. And as we go through our proof journey, you're going to see why that's the case. So the next page is just going to be looking at a couple of our rules and theorems and really starting to introduce those to you guys. Again, that properties cheat sheet is going to be your best friend. What you're going to do is you're going to try to identify the ones that are closest. So if I look at this one, A is the midpoint of BC. It's going to be the midpoint theorem. We're going to practice these over and over until you guys begin to recognize, because the midpoint theorem tells us this is a specific rule. Vertical angles. That 1 is vertical to 2. That's the definition of vertical angles. So you guys will see, I'll do a couple more of these. But it's really just understanding, and I'm just trying to get you guys to read through these rules, try to match up which one works. So let's look at a couple more. Well, it says number 21, 5 and 6 are a linear pair. Well, because they're a linear pair, we can assume, or we can prove through the linear pair theorem that those are supplementary, meaning they add up to 180. And then another fun one, number 24, ABC. If you add those two together, you make up the full line. That's our segment addition postulate. So on the second page of y'all's homework tonight, you guys are going to do what we just did right here. And I want you guys to just read through that cheat sheet that it's provided and then see how well you can come up with those. So this is not going to be graded on your homework. It'll be the page that looks like the front page where you can assume or can't assume. But this is really starting to introduce those things to you guys. All right, y'all have a wonderful rest of your day, and hopefully I'll get to see you on Wednesday.